Good afternoon. My name is Mihir Gaikwad and I am here with my co-author Prathamesh Asole. We are here to present our research name, Effective Study of Machine Learning Algorithm for Heart Disease Prediction. So the agenda for today's presentation is, we will start by introducing what heart disease is and some statistics related to it. Then we will list down some objectives of our research. Then we will go through some related researches carried out in the past. Then we will take a look at the methodology, that is our way of predicting heart disease, and then we will end up with the result and conclusion. Introduction. According to World Health Organization, 17.9 million people died due to heart disease in the year 2019. As the population rises, diagnosing it gets more challenging. As a result, early detection of heart disease will benefit people all around the world, allowing them to obtain vital treatment before it becomes life-threatening. Heart disease, considered to be very difficult to predict, detect, and diagnosis medically. Treatment for heart disease are provided at very high cost, as heart disease is one of the major public health concern with excessive alcohol consumption, cigarette smoking, etc. Let's take a look at some objectives of our research. We started with this research paper to detect heart disease at an early stage, and it is less harmful for the patient to get it treated at an early stage, as stage 1 disease is easier to be treated than a stage 4 disease, and it is less expensive to treat that disease at an early stage. So by applying these machine learning techniques in medical field at an initial stage, we got to know or predicted that a person is having a heart disease or not. That resulted in increasing the chances of that patient survival, and it also reduces the cost of the treatment, so finally upgrading the healthcare values and saving people's life. Now there are some researches related to heart disease that has been carried out in the past, some of which are heart disease prediction using machine learning algorithm, a comprehensive investigation and comparison of machine learning techniques in the domain of heart disease. But the reason for us to carry out this research was to increase the accuracy of our prediction so that we can see the patient diagnosis at an early stage. We tried to reduce the complexity of our prediction model so it is less expensive or inexpensive with respect to time and complexity. Hence, it increased the efficiency of our prediction. To best utilize our work, we design a web application in which the patient enter his medical details, and our model predict whether or not the patient has heart disease. Methodology. Let's look at the methodology diagram. So yes, we started with the UCI dataset, that is a stat log data. Then we pre-process the data and then did feature selection and use these algorithms, namely support vector machine, random forest, gradient boosting classifier, logistic regression, decision tree, and compare the result, that is the prediction accuracy of these models, and later we save best model in a pickle file, and then finally we predict if a person having a heart disease or not by using the web application having a model with the best accuracy. So these are the 5 algorithms that we have used, which are support vector machine, SVM, gradient boosting, decision tree, random forest, logistic regression. Data pre-processing. We converted male and female in the dataset to 1 and 0 respectively, etc. Select scaling data to bring all the features to a same level of magnitude. So this means the data will be within a specific range, for example 0 to 100 or 0 to 10. It is also called as feature scaling. We have total number of records, which is 270, out of which 75%, that is 202 records, we use for training, and 25%, that is 68 record, we used for testing. Here pie chart. Here you can see 44% of people having a heart disease which has colored in orange, and in blue color we can see 56% of people don't have heart disease in our data set. Next one is heat map. Let's talk about heat map. Heat map is used to visualize the correlation. We use Seaborn library here, that is SNS. We took all the row from column 1 to 14. We can see the correlation between each column. We can see how one column can influence the other. So it looks like age has a positive influence on FPS, and cholesterol has a negative influence on gender or sex. According to the color, we can predict the influences. The darker color makes positive influence and lighter color makes negative influence on one another. Pair plot of diagnosis with other features. What data we wanted to pair with, or what column we wanted to pair with or match with. We use Seaborn library here to compare the rows of index 1, 4, 5 and 8. As we can see, the target 2, that is orange color, means having a heart disease, and 1, that is green color, not having a heart disease. So this pair plot diagram help us to find the relationship between the features. Result, as you can see, support vector machine model gives us the accuracy of 82.35%. Random forest classifier gave us the accuracy of 75%. Gradient boosting classifier gave us the accuracy of 79.41%. Logistic regression accuracy is 80.88%. Decision tree classifier is 76.47%. And on right side you can see right image, there is a result that we got on web application. In conclusion, we just wanted to say we implemented 5 machine learning algorithms, namely support vector machine, random forest, gradient boosting, logistic regression and decision tree classifier for prediction of heart disease, and compared the accuracies of all to find which one of them will be the best suited for the prediction. We came to know that support vector machine is best suited algorithm for prediction, as by using it we had almost pinpoint accuracy on UCI machine learning repository for StatLog hard dataset. Hence, using the support vector machine algorithm, we set up a web application that can predict whether a person is having heart disease or not. Yeah, thanks. And we are ready to take questions. Thank you.